the polynomial division by a linear binomial. Okay, linear means x, right? And binomial just means two terms. So I'm just going to give you a couple examples. So you can't, it says the linear binomial you divide by must be of the form, like something like, I don't know, x plus 1 or x minus 6 or I'm just making things up. As long as it's a plain x and a plain number, no x squared, no number in front of the x, something in that format. Can't have a number in front or this process doesn't work. Now, it does not work for, so like if I had, this would be quadratic. I don't know, like if I was dividing by this, it says of the form that's linear, but this would actually be a quadratic. If it doesn't start with a plain x, or if you have something like, I don't know, 3x minus 2, or I don't know, 5x plus 6. I'm just making something up. But if it has a number in front of the x, you cannot use this. If it has a quadratic, like it's x squared, or if it's x cubed or something, you're trying to divide by that, you cannot use this method. However, this can save you a lot of time if you do have a linear binomial of the form where it's just x minus a number, x plus a number, which is what we're going to go through. This is very weird, I'm not going to lie to you, but once you get the hang of it, it can cause the division process to go super fast. So over here, this is just going to explain to you what I'm going to do, but I'm going to walk you through it. I'm not going to read it to you. So I'm going to divide this lovely cubic polynomial that has 4 terms by x minus 3. Okay, this is going to be weird. When you set this up, it eliminates using any of the variables until the last step. So we're just going to use coefficients to do this. Whatever you're dividing by, so I'm dividing by x minus 3. What I'm going to do is, this looks like a negative 3, right? You're just going to change that to be the opposite. I'll just put a positive in front of it. I'm going to change that to be positive 3. And I'm going to write, like, it looks like a little backwards L shape. I'm going to separate that. Now, what I'm going to do to complete the setup process, I'm just going to write the coefficients of each term of that polynomial. So, like, I have a 5x cubed, I have a negative 6x squared, I have a 4x, and I have negative 1. You don't need to involve any of the variables. And then you're going to leave yourself enough space to at least write a number underneath here. The reason you change this number, like it was x minus 3, this would actually be the 0 if we were thinking about it in that format, but this allows you, instead of subtracting like you do in each step of long division, if you change that up, that allows you to add, which usually makes it a little bit easier for people. Okay, now I'm going to color this a little bit, which will hopefully let you guys kind of see the pattern. Like I'm telling you, this is weird. Once you get the hang of it, though, it's not hard to do. The very first step, you just take that very first, whatever that number is, this is a 5 here, you just bring that down and you write that below the line. That's the very first step. Okay, once you did that, everything else is going to kind of like go from left to right, and it's going to be the same step, but the first thing after you set it up is just to bring down that first coefficient. Now I'm going to grab my highlighter to kind of show you what I'm going to do. You're going to take this number on the outside, which is 3. You're going to multiply it by the number underneath the line, and then you are going to put the result in the next open spot. So I'm going to do 3 times 5, and then that goes in the next open spot above the line. Once you do that, you're going to add the 2 numbers that are stacked on top of each other. So I'm going to just do negative 6 plus 15, or just be like 15 minus 6. So this would be 9. And then you repeat the process. I'm going to grab a different color here. So then you take the number outside, well, the 3 here, multiply it by the number under the line, and then put it in the next open space above the line. So I'm going to do 3 times 9, which is 27. And then above the line there, you're going to add the numbers stacked on top of each other. So I'm just going to do 4 plus 27. This would be 31. And then I got to do this one more time. So I'm doing 3 times the number under the line, put that in the next open spot above the line. So 3 times 31 is 93. And I'm going to add the 2 numbers stacked on top of each other. So I'm doing negative 1 plus 93. which is 92. Okay, now, I know it doesn't look like much right now, but I have my answer. So, I'm going to go all the way, I'm going to go backwards from like how you would read. I'm going to go from right to left. So, this number on the far right, this is your remainder. Then the 31 would be your plain number, like your constant. And then I'm going to have an x, and I'm going to start adding powers of x. So it's like reverse, reading in reverse, but standard form. So the first thing you see all the way to the far right is your remainder, then your constant or your plain number, then x, and then powers of x. So in this case, I have 5x squared. So here's how I would write my answer. It'd be 5x squared plus 9x plus 31, and the remainder would be 92. Yes.
And it doesn't work when you multiply. When you're dividing it by like x squared minus.
Right, it has to be a linear binomial. Yes.
To get a like non-linear binomial or equilinear binomial?
Not that I know of.
That could be hypothetically square root everything.
I don't think so. If you had like a perfect if you had like a x squared minus 4x plus 4, and you could do like x minus 2 and x minus 2, you could double divide, which we are going to do that, but later in the unit. But I can't think of a way to do that right now, and I'm not trying to like hide something. I really don't know how. Okay, so what this means, and you don't have to write this down if you don't want to, but it means if I did that x minus 3 times the 5x squared plus 9x plus 31, I'd have to add 92, and then that would give me what we had up there that we were dividing. So that's what that means, because I divided that by the x minus 3. So it's not a factor because I had a remainder, but just to keep that in mind. So let me do this with you guys again. I know it's super weird, but once you get the hang of it, it's actually really, really a faster way to do this if you have this as an option. So immediately I look at this and I see, okay, I'm going to divide by x plus 4. So I'm like, sweet. So first thing you do, change what that number looks like. So that looks like a positive 4 to me. So I'm going to write negative 4. And then I'm just going to separate it. It's like a backwards capital L shape to separate it from the coefficients. So then I'm going to go, okay, we got 4x to the 4th, 16x cubed, 6x squared, 19 x's, and then just a negative 2. Leave yourself enough space to write a number underneath there, and then I'm just going to draw a line. Now, the whole reason to change this number up is so we can add the numbers stacked on top of each other. It's a little bit easier to work with if we have that. But the very first step, just take that first coefficient that you wrote down and write that below the line. And then that's going to start the entire process. So again, you don't have to use a highlighter. I'm just going to try to show you how this goes. So you bring that down, and then we're just going to multiply and add and multiply and add and repeat. So I'm going to take the number outside here, negative 4 times 4. You put that in the next open spot, which is negative 16. Now, if you actually add right here, right, 16 and negative 16 is 0. All right, then I'm just going to repeat. So I'm going to multiply and then put it in the next open spot. So anything times 0 is 0. And I'm going to add that to the 6 that's stacked on top of it. So 6 plus 0 would be 6. And then we're just going to repeat. So then I'm going to multiply by the number below the line, put it in the next open spot above the line. So negative 4 times 6, guys, is negative 24. Add that to the 19. So I'm going to get negative 5. And then I'm going to try to use the color I haven't used yet. And negative 4 times negative 5, that goes in the next open spot. That will be positive 20. And then you add the numbers stacked on top of each other, so that would be 18. Now, all the way to the far right, this is your remainder. Then you have your constant term, so your plain number, and then you start adding powers of x. So the 6 would just be an x to the first, and then x squared, and then x to the third. Now, in this particular case, you guys will notice I had no x squareds. So when I write my answer, I would just write 4x cubed plus 6x and then minus 5 with a remainder of 18 because I really had no x squareds. And then to answer that question below there, it just says, is x plus 4 a factor? We have to say no, because we had a remainder. If it's a factor, you won't have a remainder. It means it divides in evenly. And we're actually going to divide by the same thing on the next question, but we're going to use a different polynomial. All right, so again, you're just going to switch up. This is x plus 4. Change that to negative 4. That just allows us to add. Write down your coefficients. So we got 2, 3, negative 27, and 28. Leave yourself a little bit of space. Okay, the very first step is just to bring down the first coefficient and write that below the line. So bring it down. Then we're just going to multiply, add all the way down. And I'm going to try and grab a different color. All right, so I'm going to do negative 4 times 2. That goes in the next open spot, which is going to give us negative 8. Just add the numbers that are stacked on top of each other. So 3 plus negative 8 would be negative 5. And then we're just going to repeat. So then I'm going to multiply, put the result above the line, and then we'll add. So negative 4 times negative 5 is 20. These guys will add up to 0. And then repeat. So negative 4 times 0 is 0. That goes in the next open spot. You don't have to use the highlighters or anything. I'm just trying to practice this. 7. And then the last step, you're going to multiply. Negative 4 times 7. This is negative 28. So in this case, I have no remainder, so this will be a factor. The 7 is your plain number. You have 0x, and then you start adding powers of x. So negative 5x squared, 2x cubed. So this would be my answer. 2x cubed minus 5x squared. Okay, now 0x, I don't have to write that because it would be nothing. And then plus 7, no remainder. And then my answer to the question here would be yes, because I didn't have a remainder. If you wanted to try this with long division, we should get the same answer. It's just a little different process for doing this. So you just bring down that first term, and then you multiply, add all the way down until you get to the end. Is anybody having a question? Okay, now I'm going to do a couple on the back. This is super, super important. When we did long division, I told you kind of it's optional to put a 0 if you're missing a power of x, just to help line up the digits. If you are doing synthetic division, if you are missing a power of x, you have to put a 0 when you set up the problem. So you don't have to rewrite this, so I'm just going to write this above real quick. I have x to the 4th. I do not have an x cubed in this polynomial. Minus 4x squared. I also do not have an x, and then I have a plain number. So if you're going to do synthetic division, if you are missing any powers of x in standard form, you have to put a 0 when you set this up, or it won't work out. If you're doing long division, it's optional to help you with place value, but I would recommend it. But for synthetic division, it's not a choice. If you don't put zeros in place of those coefficients, it'll mess everything up. Okay, so I'm going to divide this by x minus 2. So I'm going to change that up to a positive 2. And my coefficient. So if I just have x to the 4th, the coefficient would just be 1. Super important, I have no x to the 3rd, so I have to put a 0 there. I do have an x squared that has a negative 4 in front of it. I do not have an x, so I have to put a 0 to represent that. And then constant term there, plain number, we have negative 11. The very first step is just to take that first coefficient and write it underneath the line. And then I'm going to just multiply, add all the way down. So I'm going to do 2, number outside, number below the line, and then put the result in the next open spot. So 2 times 1 is 2. We're going to add 0 to that, so I'm actually just going to get 2 again. And I'm just trying to use different colors to show you this, but you don't have to. So 2 times 2 is 4. And that actually adds up to 0. I don't want you to think that happens every time, but I think I have several examples that happens with here. 2 times 0, anything times 0 is 0. So if I add that to 0, that's going to also be 0. And then I have one more. So I'm going to do 2 times 0 again, and again I'm going to get 0. And you just add the numbers that are stacked on top of each other. So negative 11 plus 0 is going to stay negative 11. Now, whatever you have on the far right, this is your remainder. Then your constant, your plain number, which we don't have here. Then x to the first, and then x squared, and then x to the third as you go like backwards, right to left. So I do not have either one of these terms that I have to worry about. So I have 1x cubed plus 2x squared, and then my remainder there is negative 11. If you have a 0, you don't have to put that in as you write it down. So I did not have an x and I did not have a plain number. I just had that x cubed plus 2x squared, remainder negative 11. Not a factor because it did not divide in evenly, but it didn't ask me for that. We're just practicing with missing powers of x here. Okay, let's try one more. Now, again, if you're missing any powers of x, right, I have x cubed plus 125. So I have x cubed, I have no x squared, I have no x. So I'm going to need 2 zeros to set this up that I don't have written in the problem as it is. I'm going to change up that x plus 5 to negative 5, and I'm going to write 1, 0, 0, and 125 for my lovely coefficients. Bring down, after you set it up, you just take that very first thing you wrote down for your coefficients. It's 1 for this question. You write it below the line. All right, and then I'm just going to multiply and add. So I'm just doing negative 5 times 1, that's negative 5. I'm going to add that to 0, so that's going to stay negative 5. Negative 5 times negative 5 is positive 25. Add that to 0, that's 25. Negative 5 times 25 is negative 125. So in this lovely example, I do have a factor because my remainder is 0. Your plain number is 25. And then after you got your constant, you're going to do x to the first, then x squared. If we had more, you just keep adding powers of x. So my answer here, this would be x squared minus 5x plus 25 if we divided our x cubed plus 125 by x plus 5. Does anybody have a question? It's not horrible once you get used to it. All right. Now, the 2 at the bottom, it's just going to give me 2 different pieces of information. So this one says completely factor the polynomial. This says given that x minus 2 is a factor. Okay, if they tell me this is a factor, I immediately know that if I divide this, I should get no remainder, right? If it tells me it's a factor, there's not going to be a remainder. So I know if I get a remainder that I screwed something up. So I'm going to divide this. And what it's trying to say to you there is after we divide it, whatever our result is, we'll probably be able to factor a little bit further if it's asking us to completely factor this. So I'm going to change that x minus 2. I'm going to change that up to a 2. Write down my coefficients. You're not missing any powers of x here. I have 1x cubed, negative 16x squared, 76x, and then negative 96. So no missing powers of x. I'm going to bring down the very first coefficient, which just means I'm going to write 1 under the line. And then I'm just going to go down and across like multiply, add, multiply, add. 2 times 1 is 2. Add that to the number stacked on top of it. So this would be negative 14. 2 times negative 14. Don't judge. No, I know what that is. What is it? It's negative 28, right? Okay, we're going to add the numbers stacked on top of each other. So this is going to give me 38, 48. Something. Don't judge. 48. Okay, sorry. 48. And then 2 times 48 is 96. Now, that's what we expect because I knew it told me in the directions that that x minus 2 was a factor, so I should not have a remainder. What we have here, the 48 would be your plain number, then negative 14 would be your x, and the 1 would be x squared. So here's what this means. X minus 2 times x squared minus 14x plus 48. That would give me, if we foiled that out like a little foil on steroids or drew ourselves a big box, that would give us that original polynomial. Now it says in the directions, write it in completely factored form. If it's saying that to you, it's trying to tell you the intention that like whatever we got here can be factored further. That's what it's trying to tell you. So I'm going to keep my x minus 2. Can you guys think of 2 numbers that when you multiply them, like I'm just looking right here, multiply, I would get 48. Same two numbers would add to get you negative 14, negative 6, negative 8. Yep. So then this would be the completely factored form. We're using that first factor to break that down, and then we can factor the quadratic. Okay, now, the other one that's next to this gives you a little bit different piece of information. So this says that x minus 2 is a factor. Okay, now this one says to you, given that negative 5 is a 0, and you'll notice that this one is set equal to 0, so it's a little bit different than the last one, was just an expression. If negative 5 is a 0, can you tell me a little set of parentheses that would divide into that polynomial if you know that negative 5 is an answer? Like, what would be a factor? Exactly. All right, so if this is a 0, then x plus 5 is going to be a factor. So if I know that, then I can divide that into that polynomial, which is what I'm going to do. Now, you notice whenever we've done that, we've switched up what we've actually written from the little format in the parentheses. If they give you the 0, that is the number that's going to go outside the little box, but I'm going to use this to break down that lovely polynomial. So we're not missing any powers of x. I've got 1x cubed, 8x squared, 5x's, and a negative 50. I'm just going to bring down that first coefficient to start everything off. And then I'm just going to multiply and add all the way across here. So negative 5 times 1 is negative 5. Add that to 8, we're going to get 3. Negative 5 times 3 is negative 15. Add that to 5, we're going to get negative 10. Negative 5 times negative 10, this is what it should be. Because if I know that's a 0, I should know that x plus 5 is a factor. So we should not have a remainder, which we totally don't, so that's good. Now, in terms of my answer here, the negative 10 would be your constant, your plain number, and then you have x to the first, and then you start adding powers of x. So I'd have just a 3x and a 1x squared. So in terms of my factored form here, we divided in that x plus 5, and we got x squared plus 3x minus 10. Technically, I should set that equal to 0 because they gave me one of the zeros. If they're asking you to completely factor it, they're trying to imply to you that whatever is here is something that can be factored farther. For this one, can you guys think of two numbers? They're going to multiply to get you negative 10. Yes, positive 5 and negative 2. I already heard somebody say it. So another x plus 5 and an x minus 2. Now, you can leave it like that if you want to, or I would maybe notice I had two x plus 5s. So x plus 5 can be written as x plus 5 squared there. And especially if we had to, I know it doesn't ask you to graph it, but if we did have to graph it, then we would know that we'd have a bounce on negative 5, but just as an option. Okay, is anybody having a question? So all the problems on the homework should just practice this. Yes. Yes, you may. All the questions on the homework are just to practice this lovely